So, we are going to do a lesson that reviews some of what I think are the most important mathematical skills that you have to have coming into grade 11 physics. This is not an exhaustive list, but it looks at the crucial things that you're going to need over the next 5 months in this course. First and foremost, we come to the ability to work with variables. Almost everything that we're going to describe this semester deals with equations, and we need to be able to manipulate formulas without having to substitute numbers all the time. So here's a quick little example. The formula for the surface area of a cylinder is given by A equals 2 pi r squared plus 2 pi rh. And you might remember this from grade 9 EQAO math, the math exam. And what we're going to say is determine an expression for the height of the cylinder given its area and its radius. So what this means is take this and rearrange it so that we get an expression in terms of h. And so, no problem. We'll begin by writing our expression, 2 pi r squared plus 2 pi rh. And we'll notice right away that this term right here does not have h in it. Our goal is, of course, to isolate this h so that we can get it by itself. And this term here, we're going to move over to the other side. Now, if you were going to do this in numbers, you'd say, hey, if I have an 8 on this side and I want to move it to the other side, I'm going to subtract 8, so it's exactly the same thing. We say a minus 2 pi r squared. And what we're left with is 2 pi r h on this side. No problem. Now, we want to continue this trend. And so we say we have this 2 pi rh sitting here. Let's divide both sides by 2 pi r, because what this is going to do, what I do to one side I have to do to the other side, what this is going to do is, of course, cancel or simplify this expression, so I'm left with only h sitting on this side, which is what we wanted in the first place, and I get a minus 2 pi r squared, all divided by 2 pi r. Is this fine? Yeah, this is no problem at all. You could leave this as is, put a box around it, and for our intents and purposes, you've accomplished what was set out to do. Very often, however, you'll see people simplify this into a number of different expressions, 2 pi r minus, and of course if we separate out this numerator, we get r, and that would be equal to h, and this would be a simplified expression. But of course, that's neither here nor there. This is just a little extra that you can do. But even this previous line, this is fine too. So lots of practice for you in the homework. Let's move on to quadratic equations. All right, so this is classic grade 10 mathematics. We know that quadratic equations look like this: ax squared plus bx plus c, where a, b, and c are constants, or they're integers, okay? So a, b, and c are all integers, and we find the roots of this equation. So we can factor, or we can use the quadratic formula, which is shown right here. And we're going to launch into these two expressions right here. Now, the one thing that we should say before we get too much farther, we're going to, example 2, we're going to solve this. If we can factor it, we're going to try and factor it. Okay, so first things first, let's look at part A here, and we get 3x squared minus 108 equals 0. And so this is no problem. initially we would say, oh, maybe we can't factor this, but of course the first thing that we're always going to look for is that common factor that we can pull out. And of course, yes, indeed, there is a common factor, and it's a common factor of 3 that we pull out. And then we recognize that this bracket here is a difference of squares, and we can factor this further by saying x plus 6 and x minus 6 is equal to 0. And then so the roots of this equation come from these two brackets. What value makes this equal to 0? And we'd say x plus 6 equals 0. So x is equal to -6 is one of our roots. And very similarly, x minus 6 equals 0. So x equals plus 6 is our other root. And that is, should be, and indeed is, very much review for probably every single person that's watching this. This would be a review, right? So this is how we factor. Now, part B looks a little bit different. We got x squared plus x is equal to 90. Now, what we know is that we can't have it in this form. We've got to move this over to this side. It's got to be equal to 0. So we've got x squared plus x minus 90 is equal to 0. And this is, as we know it, a trinomial. A trinomial means 1, 2, 3 terms. And we're going to factor this by looking for two numbers that multiply together to give us 90, and that, negative 90, and add together to give us positive 1. And you're thinking in your head, and you're probably already working ahead of me, that the two factors are going to be x plus 10 and x minus 9. And this is now factored. And of course, then we can say over here, x plus 10 is equal to 0. So x is equal to -10 is a factor. And x minus 9 is equal to 0. So x equals 9 is a factor. And there we have them. So, this is factoring. Every once in a while you'll come across a problem that, where this might be useful. But the really, really important essential learning that applies to physics, this is an essential learning from grade 10 math, but one of the really important essential learnings as it applies to physics is, okay, what happens when you can't factor? Or what happens when instead of these really nice round numbers in here, like 3 and 108 and 36, because these are very perfect numbers, what happens when you don't have that? Because most of the time in physics we're going to have decimals, and so you can't factor something with decimals. You could, but most of us can't think quickly enough, so we turn to the quadratic equation. Okay, and so here is an example where we have 4x squared minus 10x minus 25 equals 0. And so what we want to look for here is we want to look for these coefficients. So here's a coefficient, here's a coefficient, and here's one of the coefficients. And of course we know that whatever's in front of the x squared term, we're calling this a. Whatever's in front of the x term, we're calling this b. And the constant term, we're calling c. So that now when we turn our attention to the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. We can substitute our values for a, for b, and for c into this expression, the quadratic formula. All right, so we get negative 10, which ends up being plus 10, plus or minus square root of negative 10 squared minus 4 times a, which is 4, times c, which is negative 25. You'll notice that I'm taking the sign that's in front of the number, if there is one, because that's included in that coefficient. This is all divided by 2 times a, which is 4. And if we go through this, this is what we get. 10 plus or minus the square root of 10 squared. Negative 10 squared is, of course, just 100. 4 times 25. The two negatives here will cancel out, and we get 400. And this is divided by 8. So let's come up here and we'll calculate this out. If we simplify this down, and you can do this on your calculator if you want, we get 10 plus or minus the square root of 22.36, all divided by 8. This 22.36 comes from, of course, the square root of 500. And we can now factor, and we say x is equal to 4.045 and x is equal to negative 1.545. And those are our two roots. Of course, if these had been measurements that we had put in here, this is more of a math question than it is a physics problem. But if these had been measurements, these answers right here would, of course, been rounded to the correct number of significant figures. But because these aren't measurements, we're not worrying about significant figures. And this is basically how we do a quadratic, how we factor using the quadratic formula. All right, so moving along, solving a system of linear equations. So you remember these ones every once in a while. We won't have enough information in one equation, and we won't have enough information in a second equation. So what we need to do is we need to take two equations that have the same variables and link them together. Right? So we can solve a system of two equations and two unknowns. That we would then can solve a system of three equations and three unknowns. But here we have equation 1 and equation 2. And what we want to do is we want to solve this. Most of the time in physics, we're going to solve by the method of substitution. Okay, that's what we're going to do most of the time. And so let's take a look at this. So first things first, I would say rearrange equation 1. And we're going to rearrange it so that we move this y over here to the other side. So we get x is equal to y plus 3. So here it is. And now that we've rearranged 1, we're going to substitute equation 1 into equation 2. Okay? So here's equation 2. We get 6x plus 4y is equal to 13. Okay, so this is equation 2, just as it's written. But now, instead of writing x, I'm going to make this substitution. Because I've just told you what x is equal to. It's equal to y plus 3. So here we go, we're going to make this substitution. 6, and we're not going to write x anymore, we're going to write y plus 3 plus 4y is equal to 13. And this should look familiar. This is now just a linear equation. Okay, so we can expand out this here and this here, and we can say 6y plus 6 times 3 is 18, plus 4y is equal to 13. Collect like terms, 6y plus 4y is 10y, and that's equal to 13 minus 18, because I'm simply taking this and I'm moving it over here. So 10y is equal to negative 5, and we get our root for y, negative 5 over 10, and we'll just finish this off. Y is equal to negative 1/2. All right, now many of you will remember, okay, how do we finish this? We back substitute. So that's our next step. And we take our equation for y, or our solution for y, and I'm just going to use this rearranged equation number 1, because this is the simplest. Negative a half plus 3 is 2.5. And there we have it. So the solution to this system of linear equations, therefore, the solution is, and we usually put it in terms of an ordered pair, 2.5 minus a half. And that's that. All right. So again, if this is freaking you out a little bit, or if you're uncomfortable with this, you should make a note of that, and we can come back to it and talk about it in class. All right, the last little step is right angle trigonometry. We could use the sine law and the cosine law. We're going to get to this, but this is something we're going to talk about a little bit more tomorrow in class. So example number 6 is going to be left for you to work on individually. We'll come back to it. We're going to talk about the basics first. Recall that for any right angle triangle shown here, we have these ratios. That the sine of this angle theta is equal to the opposite over the hypotenuse. Cosine of the angle theta is equal to the adjacent over the hypotenuse. And the tan of the angle theta is the opposite over the adjacent. Okay, so just remember our little abbreviation, SOHCAHTOA. And we can also use, for right angle triangles only, the Pythagorean theorem. But this is for right angle triangles only. We couldn't use this for anything else. Okay. All right. So let's keep it rolling here and look at example number 5. So we've got triangle DEF, and I'm going to draw triangle DEF for you so that you can copy this out. Here it is, DEF. This is our right angle. So we know angle E is equal to 90. Side D is equal to 5.1. So here it is down here. This is 5.1. And side F is 8.4. So here's our 8.4. And there's our triangle, and we want to solve this. Okay, so the first thing I'm going to say before I do anything else, and you can make a note of this, right? Because many of you could probably solve this right now on your own. There are lots, and I'm going to highlight that, of ways to solve this problem. Okay, so just because the solution that I'm going to show you below is the way that I've done it, that's only one possibility. So if you get the same answers doing different stuff, you're good, right? There's lots of different ways that we can approach this. So I'm going to show you what I did in my solution. I'm going to say, okay, well, I know this guy and I know this guy. I'd like to find this. So I'm going to use Pythagoras right away to find the hypotenuse. So use Pythagoras to find the hypotenuse. And the way that we say that is that E squared is equal to D squared plus F squared. We can use this because it's a right angle triangle. And so subbing in, D squared is 5.1, F squared is 8.4, and we expand 26.01 plus 70.56. I just did these in my calculator. We add to get 96.57. And then, of course, the last step is that we want to take the square root, so E is equal to 9.8 centimeters. Now, because these presumably are measurements, I'm rounding to 2 sig figs. You'll notice here I've rounded to 2 sig figs. Let's just keep things consistent. And now that we have this, let's use some trig. Use any trig ratios, right? So any trig ratio to solve for the angles. So the two that I'm going to use are sine and tan. And so let's take a look at this. Sine of the angle F. So that's this angle in here that we're talking about. Sine of the angle F would be equal to the opposite, 8.4, over the adjacent, which is the hypotenuse. So this is sine of opposite 8.4 over 9.8. And of course, I'm going to put this into my calculator. Just remember that angle F then is going to be equal to the inverse sine. You may need to refresh yourself with how to use your calculator if you haven't done this in a while. It's the inverse sine of 8.4 over 9.8. And when you do this, making sure that your calculator is in degrees and not radians, you get that angle F is equal to 59 degrees. And of course now, last but not least, I'm going to use the tan ratio. Tan of the angle D is equal to, and let's come over here and take a look. Here's angle D. This is what I'm talking about. So for this triangle, for this trig ratio, opposite over adjacent, that's what tan is. So I've got 5.1 over 8.4. Which means that my angle D is equal to the inverse tan of 5.1 over 8.4. And when I pop this into my calculator, I get that angle D is equal to 31 degrees. Rounded to the correct number of significant figures. And we'll just briefly mention that, of course, the sine law and the cosine law, the reason that these are so great is that they can be used to solve any triangle, or the above have to be right angle triangles. These can be used to solve any triangle whatsoever. So if you ever get a triangle that is not a right angle triangle, you can use these. And that is a 22-minute lesson and is quite long enough.